All right, let's look at worksheet 26, and let's do number 7. So, guesses on what U should be? Hear you guys discussing it. It's the first chunk of stuff? I'm going to rewrite it with x to the negative 1, because that'll make it look a little better when I go to take a derivative. Because the derivative is going to be, derivative of 1 goes away, so negative x to the negative 2. Negative 1 over x squared. So how are you feeling about that choice for you? Amazing, yes. Because this is du, or at least almost du. It's off by a sign. So I can fix that with the sign. So all of this is du now. So negative integral u cubed du. Again, it's about picking the correct u. If you pick the right u, then things usually work out pretty easily. I think we did antiderivative of u cubed a minute ago. So increase the power by 1, divide by the new power. Don't forget that negative sign that we threw in there to make the signs work. Plus c. So negative 1/4, 1 plus 1 over x to the 4th, plus c. Again, it's just more practice to figure out the best way to find u. You want it to be complicated enough to make your integral easier, but you don't want to make it too complicated because then the derivative is a giant mess. So it's that balance of making u be enough stuff to help, but not so much stuff that it ends up hurting you. What else? Let's do another one. Julia?
Go for number 20.
Number 20. Okay, I would. What do you mean by do the whole thing?
Make the whole thing u.
No, I don't want to make the whole thing u because then du would be cosine of x minus 2 cosine 2x, and that would be a mess. I think what I first want to do is split this up because I know what the integral of sine of x is. Right, we can do that with addition and subtraction. You can't do that with multiplication and division, but we can split it up if it's adding and subtracting. So integral of cosine, we did this a minute ago. It's almost like I really want you to get the sine and cosine things figured out. That would be negative cosine. The antiderivative of sine would be negative cosine. And then for that second part, some people would do that one in their head. They would kind of not really do the u substitution, but just undo the chain rule in their head. Julia, did you try that, or did you try u substitution, or were you just stuck?
I was just really stuck.
Okay. Then let's do a u substitution for this one. Only looking at the second part, because I got the first part without having to do any. I could just directly anti-derivatize that sign. So what do you think u should be for number 20, or for this part?
Sine 2x.
Okay, if I make it sine 2x, then du is 2 cosine 2x. And that's not perfect because I don't have a cosine in there. So that's fine for u, but then du is a problem, so I can't use that one. So let's back up and not let u be so much stuff. It can't be just sine because that doesn't even have a u in it. So So let's do 2x. And then du is just 2. And this we can handle. So now this is u. We put a 2 on there and a 1/2 out front. So 1/2 antiderivative of sine of u du. So now it's the same problem that we just did a couple minutes ago. So negative cosine x minus 1/2 negative cosine of 2x plus c. Yeah, you could clean up the negatives, but it's also a safe stop right there. And again, some people would handle this without u substitution. They would know that that 1/2 would need to be there to undo the chain rule. What else? Let's do another one. 19. Okay. 19 kind of tricky because there's a sine and a cosine, and we know that the derivative of one of them is the other one, either way, and we can fix the plus minus stuff. So it's just a matter of, do I want u to be under the square root, or do I want du to be under the square root? I want u to be under the square root. I can't have du under a square root. I don't know what I would do with that. So that means, what do we want u to be? I think we want to be more than that. I think we want u to be all of this. Not the square root part, because then we'd have a mess on our hands for du. But if we let u be cosine of 6x, then du would be derivative of cosine's negative sine, and then chain rule we'd have a 6. So that's pretty close to the rest of the integrand. We don't do much vocabulary in here, but what we're integrating is called the integrand. I don't know that you ever need to know that, but FYI. So square root of u, that looks good, and the second part looks pretty good. I need a negative 6 to throw in there with it to make it completely like du. And that means I need a negative 1/6 out front to counter the negative 6. So negative 1/6 u to the 1/2 du. Again, it's supposed to be easy from here. When you figure out the correct u to pick, it makes life maybe not easy, easier. So increase the power by 1, divide by the new power, or multiply by the reciprocal. And again, if you don't feel like messing with fractions, like that's Monday morning, my brain's not quite awake yet to handle that, I'll just leave it as this. Obviously, a multiple choice, we would reduce the fractions there, but you could handle that. All right, do we want to do one of the yucky ones, 21, 22, 23? With the double reverse substitution business? I see nods. Which one would you like? 23. Let's do 23 then. All right, so what do you think for you?
X minus 4.
X minus 4. I think so. It doesn't directly fix our numerator problem, but it at least gets the square root to something simpler. du is dx. Okay, so progress, I guess. So I got u and du taken care of. Or I have the denominator fixed and the dx fixed, but there's still an x squared up there. It'd be nice if I knew what x was equal to, so I could replace x squared with something in terms of u. Well, what's x equal to? U plus 4. So this is that double reverse back substitution thing. So let's see what we've got here. So in the top, u plus 4 squared. In the bottom, u to the 1/2, and then du. See, again, don't do these independently. There is no quotient rule. You can't antiderivative the top and antiderivative the bottom and like put them back together. You got to do the algebra first. So u squared plus 8u plus 16 all over u to the 1/2 du. Each of these are divided by 1/2, so I can subtract the exponents. Remember, this is the same thing as x to the 7th over x squared is x to the 5th. So u to the 3/2 plus 8u to the 1/2 plus 16u to the negative 1/2. All of that was algebra. But now I can power rule all the pieces. So u to the 5/2 times 2/5. Increase the power by 1. Multiply by the reciprocal. 2/3. Plus 16. Increase the power by 1. Divide by 1/2. That'd be multiplying by 2. And we're not quite at a safe stop. We need to fill in what u is, and we're almost there. 2/5. U is equal to x minus 4. So everywhere there's a u, I'm putting in x minus 4. Yes, you could leave the fractions unmultiplied, but it's easy enough where I'm going to multiply them. And don't forget the plus c. That one we're not going to factor out x minus 4 to the 1/2, just because there's 3 terms and it would be a mess. On all the others, you factor out usually whatever u is to the 1/2, and then there's algebra to go. All right, that's good. That was quite a few from worksheet 26. We're going to do something together off of worksheet 31. It's the same type stuff, but now we'll have limits on our integral.